Activity 1.1. Building a simple VI. Open LabVIEW by double-clicking the LabVIEW icon in the desktop or access it through the Start button of the Windows. The Getting Started window appears. Click on the blank VI option to start from scratch. Two new windows should appear, the block diagram window and the front panel window, as shown on the screen. Save this VI by clicking on File, then Save. The Name the VI dialog box appears. Indicate the location in which the file will be saved in the Save In drop-down menu. Name the file as Activity1-1. Note that .vi has a .vi extension. Place a numeric control on the front panel. Right-click on an empty space on front panel or view, then Controls, Palette, Express, then Numeric Control. Click on Num Control and then drop onto the front panel. Notice that when a numeric control is placed onto the front panel, a terminal icon on the same name appeared on the block diagram as shown. The front panel and block diagram windows can be switched by pressing Ctrl E. Note: when opening Save VIs, only the front panel appears. Try this by closing Activity1-1.vi and then opening the file again. Use Ctrl E to make block diagram appear in this case. Rename this numeric control as X by typing X when the numeric label is selected. Note that the numeric control front panel and its corresponding terminal icon in the block diagram are renamed. Put another numeric control and two numeric indicators and name them as Y, sum, and average respectively. Rename terminal icon labels by double-clicking its label and typing the new label. The label of the icons is the same as the variable name in text-based programming languages. Notice the asterisk after the file name in the title bar of the block diagram and front panel windows. This indicates that there are changes in the block diagram and front panel which have not been saved. It disappears once the VI has been saved. To save VIs, click File, Save, or use Ctrl S. A node represents an object which has input and/or output connectors and performs a certain function. A sub-VI and functions are examples of nodes. Functions and sub-VIs can only be placed in the block diagram. The functions palette be accessed by clicking View, then Functions Palette, or by right-clicking empty space in the block diagram. Place an add function in the block diagram. This can be accessed in the functions, then express, then arith and comparison, then numeric. Click and drop the add node in the block diagram. Place a divide function in the block diagram. The add function will get the sum of the two inputs x and y, while the divide function will divide the sum by 2 to get their average. Wires establish the flow of data in the block diagram. To connect the X control icon with the add function, click on the X terminal icon and then click on the one of the inputs of the add function. Note: when the mouse pointer is placed over an icon or a node, the cursor automatically changes to a whirring mouse pointer, and the inputs and/or outputs of an icon or node appears. Wire the Y input to the add function and the output of the add function to the divide function. Also, wire the output of the add function to the input of the sum indicator, and the output of the divide function to the average indicator. Note: broken wires occur for a variety of reasons, such as when two objects with incompatible data types are wired. Broken wires can be removed by Control B. Since the average of x and y must be taken and displayed in the average indicator, the sum of the two inputs should be divided by 2. The first input to the divide function is the sum of the two inputs. The second input should be a constant. To insert a constant, right-click on the other input of the divide function and choose Create, then Constant. Type the number 2 when the constant node appears. Save the program. Test the functionality of the program by putting values in the controls of the front panel and clicking the Run button. After building the block diagram, it can be made more compact and professional looking by clicking the Clean Up Diagram icon in the block diagram window. Activity 1.2: Creating sub-VI. A sub-VI is a VI that is used in a higher level VI. If a VI is to be used as a sub-VI, its connector pane needs to be configured. A connector pane assigns inputs and outputs of a sub-VI to its terminals through which data are exchanged. The icon at the top right corner of the front panel or block diagram is the icon that represents the VI once it is used as a sub-VI. To assign controls and indicators to the connector pane, click on one of the slots of the pane and click a control or indicator to be assigned on that slot. Remember, controls are assigned to the left of the connector pane, while indicators are assigned to the right. If this VI is to be used in a higher level VI, it is important to edit the sub-VI icon for it to be explicitly identified. Double-click the VI icon. The icon editor window appears. The icon can be edited using the tools of this editor, which is very similar to the tools used in the Microsoft Paint. Try to edit the icon as shown on the screen, then click OK. Note: a sub-VI can also be created from a section of a VI. Use the help function of LabVIEW to find out how to do this. Click Help, then LabVIEW Help, or press Ctrl plus question mark or F1 to bring out the help window of LabVIEW. On the left pane, select the Search tab when type creating sub-VIs from sections of a VI. To list topics related to this should generate an article about creating sub-VIs from a section of VI. Activity 1.3: Using structures and sub-VIs. Create a new VI named as Activity 1-3. This VI will show the sum and average of two input values in a continuous fashion. The two inputs can be altered by the user. If the average of the two inputs becomes greater than a preset threshold value, a LED warning light is lit. Create the front panel as shown. Input 1 and input 2 are knobs. The size of the knobs can be adjusted by selecting it and dragging the edges of the selection to the desired size. Right-click the Input 1 knob and choose Properties. The Knob Properties window appears. Click the Data Type tab. The default data type of this control is Double Precision or DBL. Change this to Byte I8 type. Click OK. Then note, this step can also be accomplished by right-clicking the knob, then choosing Representation or Byte I8. For the Input 2 knob, leave the data type as Double Precision. For both of the knobs, set both to 0. Right-click the knob, then choose Data Operations, then make Current Value Default to make the default value of the knob 0. The warning LED is a rounded LED indicator. The average is a gauge. The sum is a numeric indicator. Place all of these in the front panel and resize them accordingly. At this point, there should be 5 terminals icons in the block diagram, corresponding to the controls and indicators in the front panel. Build the block diagram. The sum and average sub-VI, which is the VI created in the previous activities, can be obtained by right-clicking an empty space in the block diagram, then choose Select a VI, which brings the Select a VI to open window. Choose Activity 1, -1.vi. Note that this VI has 2 inputs and 2 outputs. To verify the labels of the inputs and outputs, roll the mouse over the VI. The sum output of the sub-VI is connected to the sum indicator, while the average output is connected to the average indicator. To enable the LED warning when the average reaches a value of at least 9, a greater or equal node is used. As said, to enable the LED warning when the average reaches a value of at least 9 or greater or equal node is used. The first input of the greater or equal node should be the average output of the sum and average sub-VI, while the second output is a constant 9. The color of the warning data is green, indicating it only accepts 1 or 0 as input. It is Boolean data type. For the VI to run continuously, the program must be enclosed in a while structure. The while structure makes the function inside it run continuously until a condition is met. In this case, it is required that the program runs until a stop button is pressed. The while structure is accessed by right-clicking an empty space in the block diagram, choose Express, then Exec Control, then While Loop. Drag the mouse until the entire program in the block diagram is enclosed within the while structure. The final front panel and block diagram should look like the one at the screen. Notice that when the while structure is placed, a stop button is automatically inserted. This is the necessary condition that the loop will terminate. In general, a while loop must have a terminating condition or it will run indefinitely. A structure in LabVIEW is represented by a graphical enclosure. The graphical code enclosed by structure is repeated or executed conditionally. A loop structure is equivalent to a for loop or a while loop statement encountered in text-based programming languages, while a case structure is equivalent to an if-else statement. To learn more about for loop and while loop structure, as well as case structure references are available in the LabVIEW help. Then save and run the VI. Adjust the knob and verify the functionality of the VI. Activity 1.4. Create an array. In this activity, a set of random numbers will be generated containing 10 elements. VIs having this function can be accomplished using an array and a for loop. To do this, create a VI whose name is activity1-04.vi. Then build the block diagram. Place the random number 0 to 1 function in the block diagram. The random number 0 to 1 function generates a random number from 0 to 1. Create an indicator in the output of the random number 0 to 1 function and name it as a current output. Place a time delay function in the block diagram. The time delay function causes the execution to be delayed by a specified amount of time. When the time delay block is placed in the block diagram, the configure time delay dialog box appears. Put 0.1 in the time delay seconds. Input box to set the time delay of the program execution to 0.1 seconds. Place a for loop structure in the block diagram, enclosing all blocks created so far inside. The for loop structure is used to repeat a certain operations n times, which is an input to the loop count indicator n in the for loop. To learn more about the for structure, refer to the LabVIEW help. Create a constant in the loop count parameter of the for loop. Set this constant to 10. Wire the output of the random number 0 to 1 function to the border of the for loop. A tunnel is created. A tunnel interfaces the inside of the for loop to the outside. The tunnel created here should contain a symbol inside. Note, the symbol inside the tunnel indicates that the data type is array. By default, auto-indexing is enabled in a for loop and disabled in a while loop. Create another tunnel out of the for loop structure, this time with the auto-indexing disabled. To disable auto-indexing, right-click the tunnel, then click Disable Indexing. Create indicators for each tunnel named Output with indexing for the tunnel with enabled auto-indexing and Output without indexing for other one. So, pwede nating palitan yung seconds kasi masyadong mabilis yung 0.1 seconds. Gawin nating 3 seconds. Then, there should be three indicators in the front panel which corresponds to the node's terminal icons in the block diagram. Build the front panel as shown. Then save the VI. Thank you very much.